Hi, so my name is Pawan Kumar. Today I will explain about the importance of data science and related information. I have more than 12 years software development experience and worked with various technologies like Perl, PHP, Python, and R and other projects. And I worked as a 3 years as a project manager and handled both data science projects and non-data science projects. Apart from programming experience, I have given training to more than 15 batches, and I am working with the different organizations to help their teams to learn data science. So we'll see what exactly the data science is. So in a simplest way, data science will have three main components. The first component is the interdisciplinary field. So data science is not just one branch that is programming. It have a interconnection with the other subject areas. We'll come to that little later. So in the first part, it's a interdisciplinary. So before data science, most of the programmers will have to work only on programming part. So they hardly any requirement to communicate with the non-IT guys. But in the data science, you have to communicate and work with the non-IT guys. The second important is extract knowledge, extract knowledge or insights from data. So the idea here is you have to extract because data has some information. That information need to be extracted. That information need to be extracted and given some relevant or usable information. The insight means something like a diamond is present inside the sand. So you had to extract the diamond from the sand. So that we call insights. What is there in that particular area? So only the expert can able to see the information which is hidden. The third component is the structured and unstructured. Data will be in a structured format. So before 2000, the most of the data is in a structured data, and like most of you heard Oracle, SQL Server, MySQL, they are structured data. So data in a tabular format with rows and columns. But now a new data is coming in the analysis that we call unstructured data. So most of the modern data science projects will work on the unstructured data. So we'll see what is the unstructured. So data science, first part is the interdisciplinary. Second is to find the information from the data. And third is the source of data can be structured or unstructured. So what is unstructured? Let us say this is the information in a one of the recent published article. So here you can see a text and an image. Suppose you want to analyze the paragraph and to understand what is the content of the paragraph, what it want to tell, or you want to analyze all similar articles in the last 5 years of data. So that is possible from data science. And here data is not in a tabular or columnar data. So you can't use any SQL query to extract the information. So this text and below the text you can see one image is there, and you want to extract a similar images from the Google database or similar images from the health database, a similar images from the a particular marketing database. So if you want to extract that, you cannot write select star from water so and so, okay, because that is not a SQL query. But how this is possible, how you can extract this, that is possible with the help of data science. So unstructured data in a format like a text format, images, audio, and even videos also. Like you can extract the content from YouTube. Suppose you want to find a dialogue of a famous dialogue. So you want to extract is there any movie which already showing the similar dialogue from the particular videos. So just before I told it require multidisciplinary subject or interdisciplinary subject. So as a data science, you have to work with the mathematicians because they have to create a new mathematical formulas to analyze a certain business problem. Statistical programming, most of our programming subject also deal with the statistics. We will cover them. So you need to talk to the statistical department people for validating your results. Information science and computer science, of course, more are much interconnected, and one more related with the hardware and other more related with the programming. So in data science, we have to see where the information comes from. Is it a text? Is it an image? Is it from a database? It is from something else. So that is the first question. Where information comes from. Next, what it represents. Suppose I want to analyze stock exchange data. So India has its own stock exchange center, America has its own stock exchange center. And these stock exchange center will send a particular data in API format. So first thing you have to see the data coming from the stock exchange. The second is what type of content is present in the API. Okay, is it only the stocks? Is it the amount or the share values or how it behaves? So that is called what it represents. So if you feel okay, the data is enough for your output, then the third question is how it can be converted into valuable resource. Because the business want a solution. Data already exists or in different format. So you have to collect the data and validate whether the data is suitable or not. If you feel it is suitable, then you have to convert into a valuable output. So data science will have this is the main component. In a simplest sense, turn raw data into valuable business information. So in a business point of view, they give you the raw data and they want a one solution. They have one problem and they want one solution. So you have to solve that particular business problem. This is my favorite one example for easy understanding. So this is like pizza. The first one is the data. So data has a raw format. They have a powder, liquid, water, some salt, some onions, all the content. So all are in a raw format. You cannot eat only the powder or you can't eat only onion. You have to combine them in a such a way that it can one can able to utilize it. So data converts into information phase. When you convert that into a product which is can be readily usable, that we call information here. Okay, at this stage it will lost all the property of the data. It's not like a raw data, it's now one can able to use it, but still information not that good or attractive to solve everything, so it need to be modified or presented in a beautiful way so that the customers or clients or the top executives can understand the output, that we call presentation. So more the look and feel will take the presentation, but the inherent is the information. Once presentation is done, it is ready to use. So in the knowledge phase, you can see the empty plate. It means one can consume that particular pizza. So they can eat that particular food. Means the purpose of data is to consume by the end client. So in a data science, it is a data, information phase, presentation phase, and knowledge phase. Knowledge phase is a more like a product where they can sell. Like pizza boy, pizza shop can sell that to the customer. So end customer doesn't know how this preparation is done. He only want whether that is tasty or not. So now we'll go with little technical details. So the program starts, data comes from the reality. Means the real world data is available, which is we collect as a raw data. The first step is the raw data collected. So as it is without any modification. And here the data need to be processed and it may need to be clean the data sets. You have to remove unwanted content and clear dust and segregate the best out of the data. Once you have that information, you have to check for the EDA. This we call exploratory data analysis, EDA, exploratory data analysis, where we will check whether the data is worth to analyze to the next level. If data is not worth, you have to discard the entire data and collect the raw data again or collect the data processing step again. So once you feel data is worth to go for the next level, the next level we go with the models. See the here, the blue one, models and algorithm box. Then we will apply the statistical models and various algorithms and to test whether we are getting the desired result. If you're getting desired result, you have to convert into visualization of the reports which is suitable for making decisions. Sometimes instead of visualizing the report, it will be sent to a product where they can sell a product to the market and that product will be sent to the real world. So data science process will have all these stages: raw data, cleaning, EDA, algorithms, visualization, product building. So in a day-to-day life, this particular graph is suitable for companies where you work. There will be four different teams will be available in the data science companies. The first person is called data surfer, second one data wrangler, third one data miner, fourth one data artistry. They are the four classes within data science. Big companies, all the four will have each one independent team will be there. In a small company, you have to all the four. Data surfer more about understand whether it's the first people or the scientists or expert statistical persons who will want to test whether or what type of data they require, whether the collected data is suitable for the next level or not. So they have some questions and they want to analyze the data. So they're more about non-programmers, more or less, more about subject matter experts. For example, like doctor, a cardiologist want to analyze the data. So he want to see the ECG graphs. So he want to see whether ECG diagrams are collected are real ECG or not, or they collected from the particular equipment or particular hospital. So he want to verify. He doesn't know anything about any programming language. He's only know about quality of the data, high level. So they call data surfers. The data wrangling, yes, this is the area where the entry level programmers will work. They will collect the data, clean the data, connect the data, and transform the data. So when we learn Python more detail, we will work on all these steps: collections, cleaning, transformation, all the kind of things. So most of the projects, 50% of the time they spend on the data wrangling. Next is the data mining. Here, like senior developers will work on it. So using various algorithms and to see which algorithm is fitting to your data, like trial and error, some knowledge from the statistical experts, and then you will get some result. Once you get a result, you have to present that result to the your client or to the organization where you're working. That is called data artistry. You have to tell what is your discovery, or present your discovery, or get back the feedback from the client or you from your organization. So all this will be part of your data science project. So depend on your experience and the knowledge, you will be placed one of these four departments. In a high level, I told it's a interdisciplinary. It's not just a only computer scientist work. So computer science people will enter into the picture. The statistical team will be present. Mathematics teams also present. Visualization team also present. There is a machine learning which you learn in the data science course. Artificial intelligence, a predictive analytics. So different people part of the data science. Everyone will contribute for the final outcome. So I often get students asking the question between the difference questions between these three. One is data science, data engineering, and artificial intelligence. So a small slide for you. Data science more looking towards driving a business. See the right side circle, the bottom circle. Data science driving a business. Data science more aim towards the output, which is useful for the business. So from business terminology, this is called data science, which will take up the data, machine learning, and data wrangling. So most of you know the Venn diagram. This is nothing but a Venn diagram. So it requires data, machine learning, and data wrangling. There is other team is called data engineering. So data engineering team more work with the infrastructure or hardware. They have to see what is the optimized GPU for this particular analysis, whether GetForce, NVIDIA 1080 sufficient or 2080 sufficient, or we require V100 sufficient, or how many clusters are required, how many GBs of RAM is required, because ordinary laptop cannot handle this work. This requires more than 500 GB RAM, not 8 GB RAM, 4 GB RAM of your laptop. It requires more about 500 GB RAM data. So huge data is required. Next one is the artificial intelligence. So artificial intelligence will require both data engineering concepts, data science concept, and adding these two, they want to develop intelligent systems. So you have to create a development product which will be intelligent one. So it can able to think individually like a human being and giving the outcome. So that we call artificial intelligence. So all the three are interconnected: data science, data engineering, artificial intelligence. So in a artificial intelligence is a part of this machine learning. So machine learning, what we do is, why we call machine learning is still a good question. We are not calling a software learning or computer learning. We are calling it a machine learning. So machine learning is not new. Generally, you think the machine learning is 2015 or 2016 uh, latest discoveries. No, this is there in 1950s. But in 1950s, the hardware is not sufficient to handle the organization problems. So even though programs, the calculations are ready, mathematical formulas are ready, they are not sufficient by using softwares. So at those times, they call this is a machine. The computer is called the machine. That's why it's called machine learning. So now machine learning is almost nothing but the software program learning, which have a do some automatic work to understand the data and predict certain information. So how they should learn on their own. See the highlighted word that they learn on their own. It's like a when you a child, a kid, we will teach the kid that this is the cow, this is the dog, this is the some animal. So when you teach them several times, next time when the child will see the cow again, he is able to identify whether that animal is a cow or not. So he is learning from the his parents, his relatives, from friends. But computer doesn't have any of this. So computer we are sending through program. Through that program, the computer will learn from the given data, and tomorrow it can identify whether it is a cow or a donkey or a some animal. So that we call artificial intelligence. So there is a slightly other teams also work with you, that them they call big data analytics, which are almost parallel to the data science work. But in big data analytics, they mostly work with a large set of data and sending the large set of data to the developer, and mostly with the Hadoop and high performance computing that we call HPC. To them, they will analyze or segregate the data. And big data analytics is a slightly different subject. It's more about converting large data into smaller data. So what you generally do in a machine learning or deep learning, if you see there's a two images are given, human eye can identify the cat, grass, sky, and other things. So in the bottom I have two images. The computer has to identify this. So the computer is taking the image borders, and when you it cannot understand by one image. So we are sending hundreds of images of a cat, hundreds of images of a grass, hundreds of images of a sky. So when you send these hundreds of images to the program can able to the software a program can able to analyze the pattern, and once analyze the pattern, they will be stored in a memory. In the next time when you send this image to the software, it is able to identify predict the output. So they said, oh, in this image there is a cat is there, in this image there is a cows are there. So that is the how the deep learning project will work, and most of the modern projects works on the image segmentation, and most of the medical or healthcare systems working on this image segmentation. And there is the other project is called OpenCV. This we will learn in the TensorFlow. So you can able to identify the various the faces, expressions, cars, car numbers, whether car is moving more than certain speed or not, whether person is using helmet or not when in bike. So you can able to analyze the various object detections. So this is the unstructured data. So this also analysis. So while learning this, it's a very huge subject, data science. So you have to know about languages. So we will learn Python part, and Hadoop is a separate subject by itself. And there is a machine learning AI tools which we will analyze in our regular classes. And we work with the Anaconda, Jupyter Notebook. In development tools, we have a Jupyter. We will learn most of our programming under Jupyter. There is a Anaconda environment is available, which is especially for data science for a Python, and that we will learn in our class. So it's very big. Different groups are there, and if you're already coming from .NET background or a Java background, you can still use Visual Studio or Eclipse. We will learn the GitHub, so different. So in my class, you will learn the Python with Anaconda Suite, Jupyter Notebook, and GitHub. This is the day-to-day usage of the various tools, and you will learn various machine learning techniques, deep learning techniques, TensorFlows, Keras, NLP, and so on. And every uh, team will work at least for two projects. It's like a teamwork, not an individual work. The companies prefer teamwork, so every team has to complete at least two projects, which they can publish in the GitHub. Classes will be daily 3 to 4 hours. So approximately given for R programming around 80 hours, and for the Python program it takes again another 80 hours. And you should know either C, C++ or any other programming language. And if you know the SQL Server, SQL, HTML is recommended. As for my details concerned, I am worked on various programming languages like Perl, Python, or PHP, Java also. And I worked from software engineer, senior software engineer level, team lead, and became a project manager, and handle the Java projects, Python projects, PHP projects, Tableau also. Then I moved to training department. Now I am giving teaching to the various students on case by case basis for the companies. And this is about my portfolio. Thank you very much, guys. If any questions, just send to me the skill rich or appropriate organization through which you can see the slides. Thank you.